Hey folks, this is the answer for Monday's problems. Again, I'll be going through Foundation Plus up to Higher Plus. Let's get started. So, our first question is essentially maybe a proportion question, proportion graphs. I think it's just reading stuff off and sort of comparing. We've got in London this camera costs £380, in Abu Dhabi it's 2,000 dirhams. In which city is this camera cheaper and by how much? Now we don't have 380 or 2,000 on here, but we need to come up with things that we can multiply essentially. So my suspicion would be, let's go from 200. Let's read that off. And that goes with £40. So we can say that 200 dirhams is equal to 40 quid. Now we can basically do most of the things we need to do from that fact. It says we need to find out the cheaper one, and a 2,000 dirham camera would be 10 times as much, would be £400. So which one is more expensive? It's the one in Abu Dhabi. So which city is the camera cheaper? We would say London by £20. For the other one over here, we want 2,200 dirhams. So again, if we know that 200 dirhams is 40, and we know that 2,000 is 400, we can put them together and get 2,200 is £440. Lots of other ways of getting there, to be fair, but that was the way that seemed easiest to me. Okay. Next off, we've got what looks like distance, speed, time. Again, you want to remember the triangle is like that. And the information we've got, 3 stages, okay, and there's some extra bits. But in stage 1, he drives at an average speed, so that's our speed, for 45 minutes. Now, the issue basically here is that the units don't match up. We've got 30 kilometers per hour and we've got 45 minutes. So you can either change your speed to be kilometers per minute, or you can change your time to be in terms of hours. I would favour changing time to be hours, because that tends to be consistent with other things. You'd have to say 45 minutes as a fraction of an hour, which is 3/4 of an hour. Or you could have 45 out of 60 and simplify it down. The speed is obviously 30 kilometers per hour, don't need to change that. And so if you want to get the distance, that's speed times time. That's 3/4 times 30, which is 22.5 kilometers. Do a little common sense check once you've done that sort of thing. If he's going 30 kilometers per hour and he's travelled for less than an hour, you'd expect to go less than 30 kilometers. In stage 2, he drives at 50 kilometers per hour for 2 hours 48 minutes, and over 3 stages he travels 200 kilometers in 4 hours. Okay, so let's do these one at a time. Call this part 1, and I'll do it up here. So for part 1 here, we've got it's stage 2 I guess, so let's label it stage 2. We've got a speed of 50 kilometers per hour. And we've got a time of 2 hours 48. Now if you're trying to convert 2 hours and 48 to a fraction, you'd want to think about 48 over 60, essentially. So 48 over 60 is what fraction of an hour 48 minutes is. That would simplify down to 12 over 15 or 4 over 5. Obviously a calculator can do that. And so this is actually 2 4/5 hour, or 2.8 hours if you want. The mistake that people will make with this is they will change this to 2.48, which would be true if it was 100 minutes in an hour. So we have speed, we have time, let's work out distance again. So 2.8 times 50 gives us 140, let's label that as stage 1, kilometers in stage 2. It says altogether over 3 stages he does 200 kilometers in 4 hours. We want the speed in stage 3. So to do that, we're going to kind of need to use the overall stuff. So overall, what's his overall distance? His overall distance is 200, we're told that here. His overall time is 4 hours, we're told that here. And so we can get an overall speed of being, 200 over 4, 50 kilometers per hour. Okay, that's less useful than I thought it was going to be. So what do we need to do for stage 3? Well, which bits do we know? Do we know distance or time or speed? So yeah, we can work out those things. So the distance travelled so far is 162.5, and the overall distance is 200. So if we take that away, we'll get that there is 37.5 kilometers left to go. And then we can also work out the time that's left over. So the time is going to be 4 hours, take away the 2.8 hours from stage 2 and the 0.75 hours from stage 1, and that will give us an overall time of 0.45 hours. Well, I think it's like 27 minutes if you were to do it that way, but decimals works fine. So average speed would be distance 37.5 over time 0.45. Cheers. Ooh, he's broke the speed limit there. 83.3 kilometers per hour. So what does that question test? Well, on the surface it's a distance, speed, time problem. And certainly the first two parts, plus a little bit of unit conversion. But the third part is testing your abilities to put together lots of different bits of information in a sort of correct order. And you can see how splitting it up into stage 1, 2, 3 and overall helps us keep stuff structured and separate. Okay. Final one, we've got a simultaneous equation. And if we want to solve a simultaneous equation, we need either the x's or the y's to be the same number. We've got 3x and 2x, 4y and 5y, they're not there yet. I tend to prefer making the middle numbers the same. So I want to get the y's to be the same number, purely because it makes it easier for me to do the next step, which is decide whether to add or subtract. So I'm going to multiply this one by 5, and I'm going to multiply this one by 4, and that'll make them both into 20y. This will be 15x, take 20y is 18. Oh, sorry, is 90. Make sure you multiply it all. And 8x, take 20y is 76. Now, do we add or subtract? So the rule we want to use is same sign subtract or different sign add. These are the signs I'm interested in. And they are both minus signs, so I am going to take away. If I do that, I'll get 7x is 14. I'll get x is 2. Cool. You can then take that value of 2 and you can substitute it back into any equation. Let's put it into this bottom one here. So 2 times 2, so that would be, let's do it straight away, 4. Minus 5y is 19. So to take away the 4, minus 5y is 15. Divide by minus 5, y is minus 3. So that's my solution. X is 2, y is minus 3. If you wanted to check it worked, you could. You could take the top equation, which is 3x minus 4y is equal to 18. Now, we said x is 2, so 3x would be 6. We said y is minus 3, so minus 4y would be plus 12. That equals 18. Yeah, it works. Or something good to do if you can. Okay, what have you got for me higher? Inverse proportion. Okay, so we should know by now that we want to be setting this out as a grid. And if it's inverse proportion, there are 3 parts to our grid. If it's direct, there are 2. If it's inverse, there are 3. We need to make sure we've got the letters right. So it talks about the force F. That's one of our things. And it's inversely proportional to the square of the distance d. So that's d squared goes here. And lastly, there's something they multiply to. So it says when F is 4, d is 3. So d squared is 9. And those multiply to 36. Now, sometimes we then have to find f if d is something, but we don't need to do that, so let's get rid of the extra bits. Express f in terms of d. So what we can get from this is that f times d squared always equals 36, but it wants this to be f on its own, so we divide by the d squared, and we'll get f is 36 over d squared. And there you go. There's your answer. Cool. So this one is actually a compass question. So what I'm going to do here is going to be a little bit inaccurate, but we'll try and explain the general methods that we want to do. ABC is a garden. Well done. A tree is planted closer to wall AB than wall BC. So if we're talking about closer to one wall than another, then we are talking about an angle bisector. Okay, so the walls we're interested in are the wall AB and the wall BC, and we're going to try and bisect this angle. Now, what does a bisector actually look like? Well, there's 2 steps, maybe 3, depending on what you call the last one. The first one is that you want to draw an arc with your compass point on B that crosses both the lines we just mentioned. So you can see I've carried that arc on until it crosses both lines. You then want to take your compass and put the pointy end on where you crossed the line, and just make sure it's like more than halfway across, and draw an arc from there. And keeping it the same width, you draw an arc from the other crossing point, and we'll end up with something like that. Now, to finish it off, so step 3, what colour haven't I used? Let's go with light green. You would then join the point B to where these 2 cross over. So that would be your angle bisector. You need to carry it on because we're talking about the whole garden, and it says a tree is planted closer to AB than BC. That means it's on this side of the wall here. Just get rid of that because that's going to look dreadful. Is there any other parts of the question? No. Show the possible locations the tree can be planted. So yeah, that's us done. So we would shade in, call it this region here. This is the possible bits that the tree could be planted in. If it says it's closer to a point than a point, that's where we do a perpendicular bisector, which is where you draw your 2 arcs and you just draw a line through where they meet. But that would be point to point. Okay. Ratio question. Okay, so this is area scale factor, volume scale factor, that sort of thing. We're told spheres have volumes in the ratio 8 to 125. So let's go volume scale factor is 8 to 125. Radius is 30. So, okay, radius is a length. So we want to get to LSF. Now the way we get from LSF to VSF is we cube. So the way we go backwards is we cube root. If we do that, we'll get the scale is 2 to 5. Okay. We're then told the radius of the larger sphere is 30. And that's going to be in the same ratio, so 30. And we want the larger sphere, not the smaller sphere. 30 over here. And then we want the radius of the smaller sphere. So how do we get from 5 to 30? We times by 6. So we'll do that with 2 as well. The radius of the smaller sphere is 12. So again, the things that you should know basically are that area scale factor is length scale factor squared, and that volume scale factor is length scale factor cubed. And everything else is just messing around with those 2 facts. Okay, last one here is probably a little bit of algebra. Now you could do this with trial and error, you absolutely could, and I think I've spotted what the answer is going to be. But let's assume we can't. How would we do this if we couldn't see the answer? We'd have to use the factor to rectangle field to draw a rectangle. 30 meters longer than wide, so let's call the width x and the length x plus 30. And then the area is 8,800. So area is base times height, or width times length in this case. So x times x plus 30 equals 8,800. And then what we essentially have here is a quadratic. And how do you solve a quadratic? Well, you certainly want to expand any brackets that are there. And then you need to get one side equal to 0. Really important that you cannot do any quadratic things apart from maybe completing the square without making one side 0. So you have like 2 marks at this stage of the question. We then got to factorise that or use the quadratic formula. Again, factorising it would work, and we'll just talk about that in a sec, but let's say we wanted to use the quadratic formula. We would be saying x is minus 30 plus minus square root of 30 squared minus 4 times 1 times minus 8,800, be careful with your signs, all over 2a, so all over 2. And then I tend to prefer working out what's inside the square root first, and that gives me 36,100. So it's minus 30 plus or minus the square root of 36,100 over 2. And then if you do it with a plus, that ends up actually being just 190. You will get an answer of 80, and if you do it with a minus, you'll get an answer of minus 110. If we were factorising it, this would factorise to 110 and minus 80, and then we get those same two answers. We get x is minus 110 and x is equal to 80. But the question is not find x, the question is find the perimeter of the field. And we've got two possible answers here. Which one of them is correct? Well, the one that's going to be correct is the one that is a whole number, because this represents a length. So we want to say that x is 80. This will mean that this length is 80 and this is 110. So yeah, it is 30 meters longer than wide. This will be 80, this will be 110, and the perimeter will be all of those things added together. So 80 plus 80 plus 110 plus 110, that would be 380 meters. So yeah, if you're given something to do with a shape, I always think it's a good idea to sketch the shape and think about the formulas that go with that shape. This is a good set of higher questions, I think. Really sort of laser focused on those 6s and 7s. Inverse proportion. Realistically, the exam considers that a grade 8, but it's not, is it? It's just a grid and you're done. I think this is probably one we found a bit trickier, because compass work is not something we've spent a lot of time on in lockdown. Scale factor, very classic. And then make your own algebra and solve it, very classic. Okay, so this means hopefully higher plus isn't too bad. Okay, interesting. So we're starting off here with an estimate. Now you've got to see the word estimate, and it means, okay, this is on a non-calculator paper for one. You've got to try and say what this is roughly. So how would you do this? Well, we'd want to think about what the indice actually means in the first place. So first thing is there's a minus. This means that whatever you're doing, it's going to be 1 over something. So we've used that. Then we have got a 3 and a 2. Remember, the top number is always the power, the bottom number is always the root. So we want to do 1 over the square root of 50 cubed. We want to estimate what this is. Now, I'm going to use the word estimate very strongly, okay? Square root of 50 is similar to square root of 49, and square root of 49 is 7. So I'm just going to replace that with a 7. And then it's 7 cubed. Now, that would be 49 times 7. I could even do 50 over 7 really there at that point, couldn't I? If we want to estimate. Times 7, not divided by 7. Which is 350, so I will estimate this as being 1 over 350. And that's fine. That's a pretty good estimate of what it would be. Let's actually just check what the real answer would be. So I'm saying, this is using a calculator now just to be sure, that this would be 0.0286 ... Whereas the actual answer is 0.00283. It's pretty good. Pretty good estimate. Alright, obviously you don't do that last step on the non-calculator paper, but it's good to know it's close. But you can see there that I've evidenced what I'm doing. So I wrote there that the square root of 49 is 7 to say why I was using 7. And then I've said that I'm switching 3 cubed into being basically 50 times 7 instead of 49 times 7. Okay. Okay, fairly in-depth one here. Now there are two ways you can do this question. I'm going to go the way that seems obvious to me, but we'll have a talk about the other one as well. And for the other one, I'm just going to leave a bit of space at the top. So I want to work out the difference between the 10th and the 20th terms of a quadratic sequence. Now, a quadratic sequence means I need to work out the nth term of the quadratic sequence. And then I need to do something with it. So remember, the way that you do that is you first find the difference between the numbers. And if it's a quadratic sequence, these will be all different. Then you find the difference between them. So the second difference is 2. If you halve the second difference, you'll get the value of a, essentially, or like how many n squareds we've got. So I know that my nth term is going to be n squared to start with. You then work backwards. So we're going to figure out what was the number for the 0 term, because we want to use that as well. So going back a term, this was a 2 still, which means that this is a 4, which means that this number here was a 0. Okay, so that's my 0 term. So that means that at the end of this is going to be plus 0. And then to get the middle bit, you need your numbers to add up to the first term. So the first term is 4, and so far we've got 1n squared, so 1 plus 0, still plus 0, and we want to get to 4, so we need to add 3 to that. So 1 plus 3 gives 4. So that's my nth term, and to be honest, you wouldn't write plus 0 normally, you'd just write n squared plus 3n. I want the difference between the 10th and the 20th terms. So I'd need to find the 10th term, and I'd do that by subbing in n equals 10. 10 squared plus 3 times 10 is 130. I'd work out the 20th term using n equals 20, which is 20 squared, add 3 times 20, which is 460. And then it wants the difference between, so my final answer would be to go 460, take 130, is 330. Now that's one way of doing it, and that requires you to understand how to find the nth term of a quadratic sequence. The other way that occurred to me is that if you could spot this sort of pattern of going up by 2 each time, you could just work it out by going forward and just keep going until you hit the 10th term and the 20th term. So I'm not going to do this all the way, but you could calculate, this is just going up by 2 each time. So next one is 54, and then add 16 to that. Next one is 70, and then add 18 to that, 88. And then add 20 onto that, 108. And then add 22 onto that, 130. And there's my 10th term. And you could keep going until you get to your 20th term, and you could do a subtraction between the two. So if you didn't want to do the algebra, that would be your other option. But I think the algebra is probably, I don't know really, maybe it's about the same amount of work. You do need to know how to find the nth term of a quadratic sequence though. Okay. Probability tree diagram, something like. X apples in a crate and 4 of them are bad. We want to choose 2 apples and the probability is 2 of them are bad is 1/11. Okay. This is very much in the grade 8-9 sort of area. So if you are looking at these grades, this is the sort of topic we need to be able to at least start. What have we got here? Our apples are either good or they're bad, and we pick 2 apples. Now, we don't want to go over the top here. We want to pick the bit of the tree diagram that we're interested in. We want to find the probability. We select 2 bad apples. We know 4 apples are bad. We know there are X in total. So probabilities that we could fill in is that the probability of bad apple is 4 out of X. And the probability of another bad apple, well, there's 1 less, so there's 3. But there's also 1 less apple, so there's 3 over X minus 1. And this is equal to 1/11. So 4 over X times 3 over X minus 1 equals 1/11. So that's our starting point. Now this is not hugely pleasant, but let's try and run it through. So if you times fractions together like that, you need to times the top together, so 4 times 3, so 12. And then x times x minus 1 on the bottom will be x squared minus x. and that's equal to 1 over 11. What we can do from here is we can do essentially some cross multiplying. We can times up by the 11 onto the left and up by the x squared on the right. If we do that, 12 times 11, 132. And then 1 times this will just be the same, x squared minus x. And you can see that you've got the thing that we're trying to show. We're trying to show that x squared minus x minus 132 equals 0, and we're done. Now it then says you need to find x, so there's a little bit of exam technique here. Even if you didn't know how to do the first bit, you can still do this second bit, because the second bit is saying, here's a quadratic, solve the quadratic, find what x is. Now if I wanted to solve this, we could use quadratic formula, we could factorize it, and we're looking for numbers that times to minus 132 and add to minus 1. It's a little bit fiddly, but if you know your times tables, you know that's 12 times 11, so we can go with a minus 12 and a plus 11. If you can't do that, you'd stick it in the quadratic formula and you'd end up with the same two things. This will give us that x is 12 or x is minus 11. And just like with the higher one where we had our area, we want to pick the positive value because we couldn't have a negative number of apples. Find x, the number of apples in the crate, x is 12, done. Okay, and then we finish off with an equally awkward one. This is tangent to a circle this time. Okay. We are proper grade 9 territory now. So, we said a couple of days ago that if you have a circle, the number at the end is r squared. So r squared is 160, and r is the square root of 160, which is nothing nice, but according to our calculators it is 4 root 10, or root 160. What does this look like? We've got a circle with that sort of radius, and where's this point that they mentioned, 4 minus 12? Positive x, negative y, so it'll be down here somewhere. We want the equation, we want to find out where that tangent meets the x-axis. So if we drew that tangent, we want to know this point over here where it hits the x-axis. So our ultimate aim, find this. How do you do that? Well, you need to know the equation of the line in the first place. We need to find the equation of the red line. But how do you do that? Well, we use a circle theorem. The circle theorem is that the radius and the tangent meet at right angles. I actually think we don't end up using the r squared at all here, which is nice. And so if we can find out the gradient of the green line, then we could find out the gradient of the red line, because they're negative reciprocals of each other. So here's our order of things to do. First thing we want to do is we want to find the gradient of green, and the points that we've got on that line are obviously 0, 0 for the origin that it starts at, and 4 minus 12 for where it hits the line, because we're told that point. So we can use y2 minus y1, 0 take away minus 12, over x2 minus x1, so 0 minus 4. This would give us 0 plus 12, so 12 over 0 minus 4, so minus 4, and will tell us the gradient of green is minus 3, which makes sense because the line is going downwards. If we've got a positive value there, we know something's gone wrong. Step 2 would be that the gradient of red is the negative reciprocal of that. Negative reciprocal of minus 3, so you flip it and you change the sign to be positive. So gradient of red is 1/3. The next thing that we need to do is we need to know the equation of red. And the formula for that is y2 minus y1 is mx, oh sorry, not y2, just y. Y minus y1 is mx minus x1. Put in the things that we know. So we know it goes through the point 4 minus 12. So y plus 12, careful on the signs, is a third, comma, x minus 4. And we could expand this, I suppose. So y plus 12 is a third x minus 4 thirds. And we could then move the 12 across to say that y is a third x minus 52 over 3, I guess. And amazingly, we're still not done, because we need to find this, as we said at the start. And this is where this crosses the x-axis. Things cross the x-axis when y equals 0, so we'd need to sub 0 into this equation. Sub y equals 0. This will give us 0 is a third x minus 52 over 3. I would multiply everything by 3 at that stage and get that it's x minus 52, and then I can just take away the 52 and get that x equals 52. So what's my final answer? Where does this meet the x-axis? At 52, 0. Absolute grade 9 question, that. Well done if you got anywhere near. It does use things that we should be able to do. We should be able to find the gradient of lines, we should be able to find the gradient of perpendiculars, we should be able to find the equations of lines, and then we should be able to find where lines hit points. But all of that at once with no sort of direction, that's difficult. Okay folks, cheers. That was Monday. I'll see you tomorrow.